All right, so this is going to be the notes that you need to copy into your ISN. Here is the layout for the first 2 pages. Let me spin this around. All right, so on the first 2 pages, you may not be able to get everything on the first page. All right, so if you can't, then what you're going to do is move some of that to the second page. So then your second page will become your third. This green sheet that's in the picture here, that's actually your blue sheet that you made that has the 8 post-it notes, and we did that in class today. So you're going to use your small foldable that says matter not matter, and the states of matter foldable. All right, so here are the actual notes that you need to write down. The stuff above that's information, that's just instructions. Nothing that you have to write down. Okay, so don't write the instructions in the little box. And then you've got some notes down here at the bottom, and it looks like some of that is being blocked. I'll tell you what that says. So we're in chemistry class. We're going to be studying the structure and properties of matter. And so matter is anything that has mass and it has to take up space. It has to meet both conditions to be called matter. Mass is the measurement of the amount of matter that an object contains. Now, once you get all that copied into your notebook, you're going to glue in the matter foldable. You need to write some examples of what matter is and some examples of what matter is not in the real estate of the tab. So, for instance, matter, people, desk, books, air, that's all matter. Things that would be not matter would be heat, light, radio waves, x-rays, those kinds of things. Once you have those examples written down, then glue in the states of matter foldable. That's a 3-door foldable, so you'll need to cut the line that's on the inside of the foldable from after you glue it in, from the top down to the crease between solid and liquid, and then do the same thing for liquid and a gas. You want to draw the molecular picture of a solid, liquid, and a gas in the real estate of each respective tab. So this would be your solid picture, this is going to be your liquid picture, and this is your gas picture. Alright, now below the states of matter foldable, you want to write gas versus vapor. Gas and vapors do not mean the same thing. A vapor occurs when a solid changes or liquid changes to the gaseous state by adding energy. So a vapor occurs when a solid or liquid changes to the gaseous state by adding energy. So that's going to go, and that should finish off your page 1. Page 2, you're gluing in the blue classification of matter foldable. Yours is blue, and this one is green. Alright, so if you'll underline the prefix homo in homogeneous mixture and hetero prefix in heterogeneous mixture, that'll help you with those 2 types of mixtures. We're going to talk about these a little bit more in class, and then put some pictures underneath here. Maybe you might as well. So never mind, I'm just going to do it now. So matter can be classified into 2 groups: pure substances or mixtures. So in the real estate, draw this picture. A pure substance, okay, is anything that has the same type of material all the way through. All right, so everything within both of those boxes are identical to everything else inside the box, so those would be classified as a pure substance. A mixture and draw this in the real estate. A mixture, everything within the sample does not look identical. So an element is going to be classified as a pure substance, and elements are made up of one type of atom. So this would be a representation of an element because it's made up of these little circle atoms. Okay. A compound is where you take two or more different, and the key here is different elements, and you chemically combine those. So those would be two different atoms, a circle and a square. And when they're touching in a model like this, that means that they are chemically bonded together. So that would be a compound. Now, there are methods of breaking down a compound so that you can get those two circle atoms and the two square atoms away from one another. And so ways that we can do this is by adding heat. We can also add another chemical to combine with that would split that. And so that's reacting with acid down here. And then a process called electrolysis, running electricity through a sample. You can also, if you shine a light that has a particular wavelength, you can also cause compounds to split. So these compounds can make the elements. They can go back down to their elemental parts. All right, so mixtures. We have homogeneous mixture and a heterogeneous mixture. For a homogeneous mixture, if you have equal size samples of the mixture, everything within the samples, the compositions makeup will be identical. So for instance, if these are the same size samples in my mixture, and the mixture has two circles and a square, so it's made up of two different types of atoms. Those shouldn't be touching right there, the square and the circle. Those are separated. But there are three different atoms in the sample. But both samples have two circles and one square. So that means that their composition is identical to all the other samples. In a heterogeneous sample, and again, you're drawing these pictures in the real estate underneath the tab and not on top of the tab. For a homogeneous mixture, if you have equal mass samples, these samples aren't going to look the same. Their composition, they're made up of different things because they're mixtures, but this sample and this sample do not look identical to one another. This is a mixture. The homogeneous mixture over here is a sample, and it's a mixture, so it's going to have different items making up the mixture. But what it does is each sample, as long as the mass is the same, each sample is going to be identical to the other samples. Now, for homogeneous mixtures, another name for that is going to be solutions, and solutions have two parts, solute and solvent. The solvent is doing the dissolving, and the solute is what is being dissolved. Okay, anytime the solvent is water, we call the solution aqueous, because water is aqua, aqueous. Okay, so that's the information that needs to go in the real estate, not on top of the post-it notes, but in the real estate. All right, we're going to leave page 3 blank, and then you're going to put the properties of matter foldable and intensive and extensive foldable. And if you can't get physical chemical change post-it notes on the bottom of this page, then put them on page 5. Here's the information that goes in the top part of the properties of matter. Physical properties of matter. These are ways that you can describe an element for simplistic sake. So when we talk about physical properties of matter, these are things that if you were to run tests to identify what an element or a substance is, it could be an element compound, well, let me back up. The test results, the tests that you run are not going to chemically rearrange the molecules. So you can melt things, you can boil things, you can freeze things, for instance, water, and making water go through all these different phase changes does not change the fact that the water is still water. So you can run those tests to get the melting point and the boiling point. Melting points are the temperature at which a solid changes to a liquid. A boiling point is the temperature at which a liquid changes to a gas. Color, odor, solubility, density, hardness, and pH test. Those are things that are not going to change the chemical makeup of the substance that you are testing. Density is mass divided by volume. Solubility is the amount of solid or solute that dissolves in a given amount of solvent or the liquid that it's dissolving in, or could be even a gas that's dissolving in another gas. Hardness is a test that you mainly would use that in a geology class where you're testing rocks to see how hard the rock is in order to identify what type of rock it is. Chemical properties of matter. You wouldn't want to use your whole sample if you're running a test on an unknown, because if you run a chemical properties of matter test, at the end of the test, you could have a totally different substance. For instance, if you take a piece of paper and you burn it, there's not any way to get all those parts together to make that paper again. So flammability, reactivity, and resistance to acids are tests that you can run, and then reactions with other chemicals. So for instance, if you have a white powder and you put vinegar on it and it releases gas, more than likely that's going to be baking soda, if one of your substances is possibly baking soda. If you put that on flour with vinegar, if it's just plain flour, you won't have a reaction occur. So these are ways that we can identify what an unknown substance is by using these tests. Physical properties of matter, you have the same substance at the beginning and the end, nothing is changed. Chemical properties of matter, when you run those tests, you will chemically alter the substance. All right, now we can classify all those properties of matter into two main groups, intensive and extensive. Intensive properties of matter means that no matter what size sample you use to run the test, the results of that test are going to end up the same. For instance, if I take a pot of water and a teaspoon of water, and I put both of those amounts in a cooking pan, and you heat the water until it boils, both of the samples there of water are going to boil at 100 degrees Celsius. It's just the teaspoon is going to boil first. It won't take as much time, and the pot of water would take a lot longer. So melting, boiling, color, odor, solubility, density, hardness, and pH test results are all tests that it doesn't matter what the sample size is that you're testing, you'll still always get the same test results. Extensive properties, the sample size does matter and it will change the results. Just like with those blocks that you measured, if you could have measured 3 black blocks that we used in class the other day, and they all had a different length, width, and height and mass. So you can't use extensive properties of matter as a reliable test to identify what a substance is. Now, you may be going to another page to put chemical and physical change post-it notes down. If you have to, that's fine. Write chemical change on one post-it note and physical changes on another, and then copy the information that's down here on chemical changes, and then copy all the information that's right here on physical changes. The words, there are many terms that mean physical change. That give you a clue that's a physical change, and there are words or terms that mean chemical change. So you'll need to memorize those lists. All right, page 5 and 6, we're going to leave page 5 blank, and we're gluing in the 2 definition foldables. And in between these, once you get this glued in, cut the line in between each one of those words so that you can open a flap for each individual definition. All right, that's just telling you what I just said. Page 7, we're going to put in these 2 graphs, but those are not glued down flat. They are anchor tabs, okay? For these 2 graphs, you're making anchor tabs, which means you're turning those 2 graphs into a post-it note by making a fold here and a fold on this one, putting glue on the back, and then gluing them down so that you can lift up the right side and it will fold over to the left. You will not have the pink post-it note. You do have the picture on page 8, but you don't have the acid base one that's below that, but you will get that eventually. So here are the instructions on how to make an anchor tab. And glue this one in. This is your heating curve. And then this is your cooling curve, which is also known as a freezing curve. The heating curve is also known as a boiling point curve. And you'll be able to tell the difference because the heating curve, the temperature is increasing over time, and a cooling curve, the temperature is dropping over time. Each part of the graph is showing a phase change or what state of matter the substance is in. So this is for one substance. So make sure you label the stuff on the front of this graph, and then the information over here that I'm circling, that's going to go in the real estate of the heating curve, and this stuff is going to go in the real estate underneath the freezing cooling curve. All right, and that's it.